For decades, India has struggled with one of its toughest challenges in aerospace, building its own jet engines. From the ambitious Kaveri program to today's missile projects, engine technology has remained one of India's biggest hurdles. But now, something significant has happened. DRDO has successfully developed India's indigenous 350 kg thrust class expendable turbojet engine, a breakthrough that puts India in a very small group of countries capable of designing and producing this tech. It may not power fighter jets, but it could become the engine behind India's next generation of missiles and drones. So why is this such a big deal? At first glance, a 350 kg thrust engine doesn't sound very impressive. After all, a fighter jet engine produces tens of thousands of kilograms of thrust. But this engine isn't meant for fighter aircraft. It has been designed by DRDO's Gas Turbine Research Establishment, or GTRE, and manufactured by Hyderabad-based Azad Engineering for single-use military systems. Think cruise missiles, jet-powered loitering munitions, high-speed target drones, and unmanned aerial vehicles. The first production engine has already been delivered to GTRE. The real achievement is in the number, 350 kilograms of thrust. It's that India can now design and manufacture this class of engine on its own. Until now, India relied heavily on imported propulsion systems or foreign collaborations for compact jet engines. That dependence often came with export restrictions, delays, and limited control over future weapon development. Now, India has taken a major step towards changing that. The word expendable might sound strange, but it is actually very simple. Unlike the jet in a fighter jet, which has to survive thousands of flying hours, an expendable turbojet has only one job: power the missile or drone to its target. And that's it. That engine is never recovered, because it's designed for just one mission. Engineers optimize it differently. Instead of making it last for years, they focus on four things: keeping it compact, keeping it reliable, keeping it affordable, and making sure it delivers enough thrust to complete the mission. This makes these engines ideal for cruise missiles that fly hundreds of kilometers at low altitude, jet-powered kamikaze drones that can strike targets much faster than propeller-driven drones, target drones used to test air defense systems. In short, this isn't just one engine. It's a platform that can power an entire family of future weapons. People often think missiles are the difficult part. In reality, the engine may be even harder. A turbojet has to suck in air, compress it to multiple stages, mix it with fuel, and burn it at temperatures above 1000 degrees Celsius, and then extract energy from the hot gases, all this while spinning at 10,000s of revolutions every minute. Even the smallest manufacturing defect can destroy the engine. That is why only a few countries have mastered this technology: the United States, Russia, France, the United Kingdom, China, and now India has joined that exclusive group. This doesn't mean India has solved its biggest challenge. Far from it. Building a reusable fighter jet engine is still an entirely different league. Those engines require far more than thrust. They must operate for thousands of hours, survive repeated takeoffs and landings, and withstand extreme temperatures without failing. India's Kaveri program showed just how challenging that can be. But it also created valuable experience that continues to benefit newer projects. This new expendable turbojet is another important milestone on that journey. Alongside, India is also developing small turbofan engines, Kaveri derivatives, and future propulsion programs for the aircrafts like the Advanced Medium Combat Air, or the AMCA. Recent conflict in Ukraine and the Middle East have also shown why these technologies matter. Modern warfare is increasingly relying on long-range missiles and fast unmanned systems. The countries that can build the engines behind those weapons will have a major strategic advantage. And that is why this breakthrough is so important. India's new turbojet engine won't power fighter jets tomorrow, but it does something equally important. It gives the country greater control over technology that powers its future missiles, drones, and precision strike systems. And perhaps, even more importantly, it adds another layer in India's long journey towards mastering advanced aerospace engines. So here's the question, could this be the breakthrough that finally puts India on the path to building its own world-class fighter jet engines? I'm Vivek Dubey and you're watching The Times of India.